back to my channel Cat by Nagendra. So now in this video we are going to create this press tool assembly in SolidWorks. Now just we'll go here with first we are going to create here with bottom up approach. So bottom up assembly is nothing but we need to create first individual single parts and we need to save it in one folder. Later we can go for assembly design. Now let's go here with part designs. First we'll start here with bottom plate part design. New part, let's say okay. So to create this bottom plate, just I'll go for top plane and I'll create one rectangle with 250 into 150. It should be extruded of 30. Later we can create these holes and this center hole also. Or else in a single sketch we can create this entire thing. Now on the top plane I'll go for sketch. We'll create one center point rectangle and by using smart dimension, length we need here 250, width we need here 150. Then along with that, I will create here one more hole with a diameter of 50 exactly at center with a distance of 50. Let me create one circle here. Dimension for this we are having here diameter of 50. Then by using relation, by holding control, this point and this point we need here vertical relation. Dimension from point to this line we are having here 50. Exit sketch, make it isometric, extruded boss. It should be extrude boss of 30. Let's give here 30. Here no need to use any mid plane. Why? Because only it is unidirectional like this. Then 4 holes are there with position of 30 into 30 with diameter of 25. Hole wizard will go here with legacy hole. Diameter of 25. Depth should be up to next. Position from this top face somewhere here. Then one we can create, later we can make it pattern. Let's use escape, make it normal. For proper position we are having dimension from this to this 30. Then this end to this, here also we need 30. Let's say same hole, total we need 4. One hole to one hole in this direction 90 and in this direction 190. So we can go here with a linear pattern with reference to this direction. Total we need here 2 instances with a distance of 90 in reverse direction. Then in this reference to this edge, we need 2 instances with a distance of 190. Feature we need to create pattern for this hole. Let's say okay, like this. Then if you want, we can apply some color for this, or else directly we can change material also. Let me apply some color. Mouse right click on part here, appearances. For this particular part, just I'll select some color. Then we will save it. So here one more tab will be shown. For that, just we can use this and we can make it here this bar. It will be shown separately. Then just I need to make here save. Let me go back. Here we'll create assembly design. And here one more folder we will create. We are going to create here press tool assembly design. Press tool assembly. Open that assembly. So first part, this is bottom plate. Let's save that. I will close this. Again we'll go for new part. So next part we are having here top plate. So for this top plate, same we need here 250 into 150 with extrude boss of 30. Then along with that, one more with diameter of 50. Material should be added downside with 90. In a single step, I am going to create that everything. Just we need one center point rectangle. This is 250 and width of 150. Along with that, we need one circle somewhere here with a dimension of 50. This to this we need here 50. Relation between this to this origin point we need here vertical relation, exit sketch. Now only this rectangle should be extruded of 30 upside direction. So extruded boss upside direction we need only 30. I am not going to select this circle. Let's say okay. Then just we will open this. We'll select the sketch or else Again go for extruded boss. Already we have created the circle under this sketch. I'll select this. Here selected contours will be there. We will delete everything. We need only the circle part. That too we need here reverse direction with distance of 90. Only that profile will get separately boss extrude like this. Then next we are having here 4 holes with a diameter of 40. Hole with the diameter of 40, then position of 30 into 30, just will create one, make it normal. Dimension from this to this, we need here 30, then this to this, we need here 30. Let's say okay, isometric. For this hole, we need to make pattern. First direction is this, second direction is this, then feature is this. Total 2 holes in that direction 90, the 2 in reverse direction. In this direction we need 190 in this direction like this. Let's say okay. Then just we'll change some color for this. So these are simple parts, so little fast I am going. Let's say okay like this. Then we will save it in the same folder where we have created is existing parts. So we need here top plate. Close it. We'll go for one more part. Next we are having here guide pillar with a diameter of 25, length of 200. Then at end we are having chamfer of 2. On the top plane I'll draw one circle with a diameter of 25. Exit sketch isometric extrude boss with length of 200. Then at end 2 into 45 chamfer. We need here chamfer for this edge and this edge with the length of only 2 mm. Like this. Mouse right click, appearance for this part. We'll apply some color. Then we'll save it. So this is guide pillar saved. Next we are having here guide bush. For this guide bush, 2 circles are there, 40 and 25. It should be extruded boss of 60. On the top plane, we need here 2 circles. One is 40, one more is 25. Exit sketch, extrude boss of 60. Then we need here chamfer for this edge, then with 2 chamfer mm, 2 mm, let's say. Again appearance for this part, just we'll apply some color. Like this we can create this separate individual parts. We will save it in same folder. This is guide push. Let's save this. Now we'll create this assembly design by using this existing parts in SolidWorks. To create this assembly design, so already we have created and we have saved parts. Let me enter into here new assembly design. Let's say okay. So here directly we are able to insert first part into assembly, or else just we will cancel this. We will start fresh. Now first I need to call this bottom plate. So in before video we have seen that how to insert like existing parts into assembly. For that we can go here with insert components option. I'll click on that. Now first I need to open this bottom plate. We can see preview here properly. Let me enlarge the screen like this. If it is not showing here, we can turn on or turn off this preview pane like this. So I need to call this bottom plate. Let me open this. Now I am able to change here orientation with reference to x-axis or y-axis or z-axis. However we want, we can change. So I don't want to change anything. Just I'll keep it somewhere here. One click. Now if you observe in this tree display, for bottom plate it is showing F. F is nothing but it is fixed. If I try to move that part, it won't move. As you can see this, you can read that the selected component is fixed. It can't be moved. So whenever we are going to create an assembly design, whatever the part we will insert into assembly design, first part automatically it will get fixed in SolidWorks. So if I try to drag, it won't come. But separately here, planar axis system will be available for this particular assembly design. Here, for this part, we are having separate planes, but for assembly design, we will be having separate planes and origin point. Now, directly if we keep it here itself, here point origin is here, assembly origin is somewhere here. So if you want, we can leave like this, or else if you want to avoid confusions and if it should be perfect in future for an assembly design, better we can make relation between this part axis system to assembly axis system. For that, I'll go here with visibility. Here we will show view origins. So origin points will be shown. Now this is the part origin, this is the assembly design origin. But if we try to move, it won't move. This part, on this part, mouse right click, we will make it here float. So if I make it float, this part will be moved freely. Directly we can keep it there itself and we can continue assembly design, but assembly design origin system will be at some point, part design origin will be at some particular position. So to make this proper relation, we need to make this float and we need to go visibility, we need to show origins. Now if you want to apply relation between this origin to this origin, as already we know, directly we can go here with mate. We need relation between this origin point to this origin point like this. Let's say okay. Now properly this part will be fixed. See, if we try to move, it won't move anywhere. Now origin, like origin of part design and assembly design will be at some same position. Then next we want to call here this guide pillars. Insert component, I need to call here guide pillar. Open that. We'll keep it somewhere here. So if you want, we can show these origins there itself, or else we can hide that. Now this guide pillar should be assembled to these holes, all these 4 holes. Just I'll go here with the mate. We need relation between this guide pillar cylinder. It should be exactly inserted into this hole. Just I'll click this. Here advantage is we will be not having any separate option to select whatever the relation we want. Whatever this proper positions where we want, if we select proper features, automatically it will take possible relation. Like as in catia, for coincident separate option, for contact separate, for angle separate. Here not like that. Simple, like in SolidWorks assembly design will be very simple. So if you select proper positions or proper parts, directly it will take possibility relation. Now you can see, just I selected cylinder and cylinder, directly it has taken concentric. So we need same thing, just we will say okay. Then here one more thing, if you want to check degrees of freedom, no need to go with any other options. Directly you can see here it is showing underdefined, and in which direction it is able to move, just you can move this part. Now this part is not able to move in X direction and Y direction, but it is able to move in Z direction. Here we need relation between this bottom face, it should be attached with this bottom face like this. If you want reverse, we can make it reverse direction, but here we don't want reverse, we need opposite upside only. Let's say, then still it is showing here underdefined, but this part is not moving. But if you check here, this part is able to rotate. So as already we know, usually we will be having here 3 degrees of freedom, 2 linear motions, 1 will be rotary motion. Here rotation is there. To lock that rotation, for this part, I'll open this tree. Why? Because this is a cylinder, we don't have any flat faces to make it parallelism relation. So you can see whichever the part is underdefined, it will show here minus indication. Just I'll open this. If particular part is fully constrained with all degrees of freedom, it won't show any minus symbol here. If it is underdefined, it will show minus here. Now this part is able to move with reference to this z direction. Just I'll select this front plane. It should be parallel to this front plane. Just I'll select that. Automatically it will select parallelism. Let's say okay. Now if you see, we are able to see here fully defined, and this minus symbol also will be not shown like this. Now this same component total we need for this all four holes. So as already we know, this multiple holes we have created in linear pattern in part design. Same directly we can use here linear component pattern. Linear component pattern. First direction is this. Second direction is this. Then we need here two instances with a distance of 90. Then here we need distance of 190. Two instances. Component to pattern is this. Properly all these four will be created like this. But here, even though if all parts got like fully defined, here it will show underdefined when we are using this linear component pattern. So no problem will be there. So usually wherever we don't want any movement of that particular parts, there here we will make it here arresting the degrees of freedom. For suppose if you want to make this part to move in assembly design like up and down direction, we should not give here coincident. Why? Because we need movement for this particular part like that. Wherever we want motion for particular parts, there we should not give any constraints or we should not apply any mates. So here it is showing underdefined, but if we try to move the part, all parts got fully defined by this. So this is also correct method, or else no, we should be like, we should get here fully defined only and all parts should get fixed means instead of using this linear pattern, we will use here copy with mates. It means we are able to copy the part with whatever the mates we have applied for this particular part by using this copy with mates. Now just I'll go here with copy with mates. Selected component. Which part we need to make copy with mates? This guide pillar we need to make. Then go here with next. Now first we have applied concentric between this guide pillar to this hole. Same guide pillar axis or cylinder shape, circular shape, it should be concentric to. Now for example I need for this hole. Select that. Then coincident we given for bottom face. Same for this guide pillar also we need coincident for this face. Select that. Then parallelism we given for this face. Same here also we need for this face. Select that. If you see here, it will show in green color. Let's say. Same I need to repeat. Concentric to this. Coincide to this. Parallel to this. Okay. One more I want. Concentric to this. Coincide to this. Parallel to this. Let's say okay. And at end we need to cancel this. You can see all components got fully defined and we got here fully defined option. Pattern also we can use, or else separately we can go here with copy with mates and we can do it. Same similar to linear component pattern. If we are having in circular direction, we can use circular component like this, different type of patterns. Mirror also we can do. Then again we will insert one more component. We need here top plate. Open that. Somewhere we will keep it here. Now mate I want between this cylinder, it should be inserted into this. Possibility is concentric. We need also same thing. Let's say okay. Then again if I try to move, this is able to rotate like this. Just we can make it here one cylinder to one more cylinder, or face to face also we can give. That is our wish. Just I'll make it here cylinder to cylinder, same concentric taken. Let's say okay. Then this part is able to move in up and down direction here. So here we are having some gap. We are having some distance where from this face to this face, automatically it has taken here coincident. It is attached to that face, but we need here distance. We can go here with distance option. Let's give some 200. Later we can edit that. Let's say. Then Again insert components. Last we will insert this guide bush somewhere here. Same similar to whatever the mates we applied for guide pillar to this bottom plate, we will apply for guide bush to top plate. Mate I want this cylinder to this hole, we need concentric. Okay. This top face, it should be attached with this top face. Okay. Then to lock rotation, here it is showing minus for guide bush. We will open that. We will select any plane with reference to this front face. We'll make it parallel. Let's say okay. Now if you check up to here fully defined, here it is not showing any minus symbol. Now this component, we will make it here copy with mates. Go for next. We need concentric for this, coincide to this, parallel to this. Let's say okay. Concentric to this, coincide to this, parallel to this. Okay. Concentric to this, coincide to this, parallel to this. So like that, in a simple way, we can finish this assembly design. Now, this height we need to adjust. We need to edit that distance mate. As you can see here, mates will be available separately under bottom. If you open here, different type of mates what we have applied, everything will be visible here. Now we need to edit this distance. We can go for edit feature. Instead of distance 200, I need only 120. And let's say like this, we can make this assembly design in a simple way in SOLIDWORKS. Then for this particular assembly design, I need to show data in a tabular column that already we know that we call it as bill of material. I'll select this bill of material here. Different type of standards will be there. Just I'll select here. Different type of standards will be there for bill of material. Like we need only with reference to this material, or only with costing, or only with stock size, or only with vendor. Whatever we want, we can select. Now let's take for example bill of material for all. It means it will be included with costing, material, standard, everything will be included in this all. Open. So usually for separate companies, they'll be having their own standard of this bill of material templates. Just we can go here with this option and we can select whichever the template we want. Then with reference to that template only, we will get bill of material. Let's say okay. Now you can see here one tabular column will be created. So item number, part number, like bottom plate, part name will be there. Description, we can just double click on that. Then we can enter whatever we want like this. Material will be shown, stock size. Usually bill of material will be shown in drawing file, so not in assembly design. So just to show this option, I have shown you in detail about like how to show material, weight, everything I'll show in drawing. So now let me delete this. That is about bill of material. Then next we are having exploded view. Exploded view is nothing but whatever the assembly view is there, we will be not able to see all the parts properly. So in such case, by using exploded view, you are able to explode the all views and we will be able to see total how many parts are there in that particular assembly design. Now let me show you this exploded view. Here, two types you will get. First, a regular step will be there, then radial step will be there. Here, regular step means whatever the component we are able to select, it will be able to move only in one direction, like upside or left side or right side, however we want, we can move. Done. For this bottom plate also, I need to move down. Done. Next, let me take this all 8 parts with radial step. This, again this and this. If I drag here, it will come in radial motion like this. This will be coming in linear motion. This will come in radial motion like this. It will explode. Done. Again, this guide bushes also. I'll make it here radial step like this. Let's say like this, we are able to get this exploded view. Again, if you want, we are able to show this line sketch also. So explode line sketch means, for example, for this hole, this part should be inserted. For this guide pillar, this guide bush should be inserted. This guide bush, it should be inserted into this hole. Like that we can show in line diagram. Again for this hole, it should be attached with this guide bush. That should be inserted into guide pillar. That guide pillar should be inserted into this hole. Again from this hole, guide pillar should be inserted for this guide bush, for this hole. Again for this hole, this guide bush, this guide pillar, again this hole. Let's say okay. Like this we are able to show this line sketch also for better understanding about this assembly design. Exit sketch. Now if you want again normal view, just we can click on one more exploded view once again. Let's say okay, we will get here normal view like this. So I hope you have understood about this exploded view, bill of material, and how to create an assembly design by using bottom-up approach in this SolidWorks. Now let's make this simple motion study simulation for this particular press tool assembly. So usually function of this press tool assembly is this top plate along with these guide bushes, it should move up and down directions here. Now we need motion up and down direction here. So here we have given like distance made between this top plate to this one. Let me delete that. We'll open here. Distance made we don't want. We will delete that. Then if we try to move, it will be moving like this manually. But we will make it here with some automatic motions. For that, we need to go here with, here you can see at bottom. Let me update here, rebuild. It is nothing but update. Now we'll go here with motion study option, motion study. Then this top plate with these guide bushes, it should move in up and down direction. So we can use here one option called motor. Just click on motor. Here two type of motors we'll get. One is rotary motor, one more is linear motor. Here we don't want any rotations, just we need in up and down direction linear motor for this component. So just I will select this component like this. Then it should be in reverse direction. We'll make it reverse like this. Then we are able to adjust the speed how much we want. Just I'll keep it same. Let's say okay. Now if I go here with this calculate option, let me click on calculate. Slowly it will move down and again it will go up like this. Let me stop here. Once if I go here with this arrow symbol, we are able to see here duration time, how much we want that motion. Then one more thing, we can go here with motion study properties. Better we need to increase this frames per second. Frames per second in the sense in 1 second how many frames visibility should be available for us. So if it is very less, we will be not able to see that motion properly. Let me give some 100 or 60, how many we want we can take. Now again just we'll make it here rebuild. Then we'll make it here once again calculate. Now properly we are able to see that how much we want. Again and again same thing we are able to see that, but we need to increase some duration. Just we can drag and we can increase the duration. Then here different type of motions, loop modes will be there. So playback mode normal is if I make it here once, only one time it will go and it will stop. Then next we are having here loop mode. Again and again whatever we are able to see, same thing it will get repeated. So just it will go down, then again automatically it will go up, again it will repeat the same procedure. Then one more we are having here reciprocate. Automatically it will go down, again it will move up properly like that. Up to the duration it will move, again it will go up like that. If you want to increase more duration, we are able to increase here, and we are able to change speed also. If I keep it here 2x, it will move faster like this. Still if we increase the speed, again still more fast, it will move like this up and down direction. So like this, just for animation purpose, we can make this file like how it should be moved in assembly design. We are able to show in SolidWorks like this. And if you want to save this separately, we can save here as save animation. Then which type of format we want, we are able to select this in which format we want. For example, I need here MP4 video format. Let me save in this same press tool assembly save. Now if I go here, then we have folder here press tool assembly. Then this is the MP4 file. If I play this, we are able to see that. Like this it will move. So properly it will be saved and we are able to save that animation file also. So I hope you have understood how to create these simple motions. So here we need up and down direction relation like a movement we want. So we should not give that mate. We should not give that constraint. Why? Because if it get fully constrained, it won't move like this. So like that, according to our requirement, we will apply what are the different type of mates we wanted and whatever we don't want. Thanks for watching. Keep supporting. If you have any doubts regarding this, please let me know in comment box. And if you have any suggestions for me to give, please will let me know in comment box. Thank you so much.